Hello, welcome everyone, wherever you may be joining us from, to Oceanology International Decarbonization Week. My name is Justin Manley. I'm happy to join you to moderate a panel discussion on autonomous and uncrewed systems on a course for net zero. If I could have the next slide, please. So in this session, we're going to be addressing a series of topics. I'm going to kick us off with a little bit of an overview, reminding folks that the uncrewed maritime systems market, this is a growth market. There's dynamic technologies and applications. And of course, there's also some rapidly evolving business and policy concerns. So I'm just going to set the stage with a few remarks. Then we have two guests who will present perspectives from industry leaders, including XBlue, our sponsor. Thank you for that. And then we will transition into an audience Q&A. And just as a reminder for all of you, in 2021, we've all used many different platforms. There is an attendee question function. Those questions will flow to me, and I will be able to help with the moderation. So that's what we're setting out to do over the next just over an hour. So if I could have the next slide, please. I'd like to open this sort of discussion, right? We're talking about net zero, which leads to words like sustainability and renewable. And I just wanted to remind everyone out there that this field of uncrewed maritime systems, or ocean robots, has actually been a leader in the engagement of renewable energy sources, wave-powered systems, wind, water-powered, both buoyancy and temperature variances, and solar systems are all maturing and essentially on market. Everything you see on this slide is a product you could engage and put to use today. So I think that's an encouraging sign. It's a nice way to start off this conversation and remind ourselves that our technology has been bringing sustainability and renewables to bear for some time now. If I could have the next slide, please. So we ask ourselves, what is the role of uncrewed maritime systems? There are environmental missions, and I selected storm research to talk about, mostly because it's so much fun. You may have recently seen some news coverage. Sail drone sailed one of their vessels into a hurricane. It's not the first time ocean robots have entered hurricanes. In fact, the Storm Glider team have been doing it so much they've developed their own logo. Right, so this is definitely a compelling application. And then if you're an engineer or just a sailor, you observe photos like those in the bottom, and you realize that we can do things with robots that, frankly, we would never do with a human-occupied vessel. So this is just one topic, one way that uncrewed maritime systems are contributing to a sustainable future. We can have the next slide, please. And this is just another example which I'm using to remind everyone that the technologies we're talking about cross-domain, right? So in this case, aerial systems, drones, UAVs, UAS, whichever moniker you'd like to use, are contributing to the study and management of marine mammals, for example. Some systems can deploy passive acoustic monitoring to help ensure that offshore construction operations are compliant with environmental regulations. Others, like you see on the top right, are actually collecting biological samples about whales to understand their health. So the technologies available to us and the environmental challenges we can engage are quite diverse, and we should remember that as we go through this discussion. If I could have the next slide, please. And I always like to ground these kind of panels in recent market news, right? This is an industrial enterprise. We're talking about technologies that deliver value. And these are just a couple of news items that have come out in the past quarter. Why are these here? Well, just for example, carbon capture and sequestration. Much of the technology we talk about in this community was inspired by the historic field of offshore oil and gas. Carbon capture and sequestration presents an opportunity to essentially repurpose all of that technology, perhaps even some of the existing infrastructure, and continue to add both economic value to those organizations and, of course, environmental value and improving our situation towards sustainability. Other interesting news items, right? So read exhibitions. This is all driven by oceanology. Most of us are joining us as oceanology attendees. So our friends in the UK with Bodie McBoatface. So Bodie is being directed at end-of-life oil field R&D questions, right? So this is an important topic area. And then most interesting, if you're following this field, maritime autonomous surface ships, autonomous cargo ships, whatever you'd like to call them, are another emerging and potentially very large market. And here we see that, including the idea of becoming large mobile batteries to transport renewable energy from offshore to shore. Again, these are just a few highlights that I point out to show that this field, uncrewed systems and sustainability, there are many intersections, many technology and market opportunities. So if I could have the next slide. This is just the end of my opening remarks. I just sort of wanted to set the stage and let everyone think about and understand we're in a big, exciting world here. This is my reminder, attendees, as you listen to these remarks, don't be shy about putting your questions in the question box, because after our next two speakers, we are going to move to a dynamic Q&A, and we want to include you, even if we can't be with you in person. So with that, I'm going to hand this over to Olivier from XBlue, who will take us through some of his remarks. And after that, we'll hear from Bjorn at Kongsberg. Olivier, the floor is yours, subject to technical systems doing their job.
Okay, so maybe I can share my screen now.
Yes, please do.
So it's, I hope everyone can see my screen sharing.
Yes, it looks good here. Thank you.
Thank you, Justin. Hi, everyone. I am Olivier Cervantes. I'm the Vice President for the energy market at XBlue. And I've worked over the last, I would say, a few years with the XBlue team on market adoption of autonomous systems, which is one of the key strategic pillar of our developments since 2015, I would say. So since 6 years from now. Maybe I will start with a short introduction on what is XBlue and what we do at XBlue. So one slide that for me summarize what we do at XBlue in mainly three main domains, three main activity, what we call maritime and autonomy, photonic, and navigation. And today we will focus on maritime and autonomy, especially on autonomous systems and how they bring value to the market. I would summarize XBlue as a technology leader pushing the boundaries from the bottom of oceans to the depth of space. We go beyond borders, and we do so through an absolute unique technology platform, which has make us, I would say, has allow us to develop more solutions for market every day, thanks to a very coherent and complementary offer. The breadth and depth of our technology mastery opens up an absolutely incredible potential. And you will see in this presentation the value of this technology master in our development in the autonomy domain. It is the second slide about XBlue and the offering, and then I will go into more detail on autonomous systems. But essentially, we see on the left the three domain: navigation, maritime autonomy, and photonics. And we have developed an offer from component through systems throughout to solutions. What you see on the left, right is in red is our latest development in terms of unmanned surface vessel named DRIX. But we've been working on autonomous systems since 20 years, I would say, at the very early stages of autonomous underwater vehicle. At that time, I was already talking to Bjorn Jalving, who is with us today from Kongsberg Maritime. I think at that time, Bjorn, you were at FFI, in Norway, and we were developing together inertial navigation system for autonomous vehicle. So we have this root and this DNA into autonomy systems. So now you see a little video running on the right side of the Drix with unique, you will see sailing capabilities. And on the left side, we see the integration of all the technology at XBlue. So we have a shipyard in the group. We have also integrated artificial intelligence, robotic company who has developed all the software, all the intelligence of our autonomous systems. We have a service capability. We develop inertial navigation systems, sonars, and motion systems. So all together, we managed to put a unique design, a unique capability, and we will see how it delivers in the market. So again, we have a unique situation in the south of France. I welcome all our friends today who are attending this webinar to come and see and visit us in the very nice area in the south of France, where we have our campus testing facilities and where we develop sonars, and we can bring you at sea to see how we use Drix and how we use autonomous systems. So this is also a very important topic. I think I enter more now into the subject of Dcarbonise, of the subject of today. Sorry, and as part of its of our plan from 2021 to 2025, at XBlue we have decided to revise and accelerate our sustainability roadmap, and this initiative is obviously aligned on the strong actions ongoing at the European level, stemming from the Green Deal, including the future Corporate Sustainability Reporting Directive, what we call the CSRD, and the European Taxonomy Regulation. So in 2021, XBlue has framed its roadmap for effective deployment over the next years. And the detailed review of XBlue materiality analysis is ongoing, which leads to the identification of our quantified goals by mid-2022. But here I put the three main actions, drivers that we already identify. So strongly support the market with an offer that is significantly contributing to climate change related trends. Strengthen our actions to contribute internally to the 6 environment-related objectives at European level, including carbon footprint. And the third point is about identifying precisely the possible threats of environment, social governance related trends to improve our resilience for the benefit of our stakeholders. So I wanted to also, probably we will discuss about that, how we integrate in our organization this European Green Deal and the challenges of doing that. So if I come back for some time on autonomous system at XBlue and our expertise in the domain, this is an image of what is the offer of XBlue today, what we call the X autonomy at sea. And we have developed a set of capabilities from very shallow water, so brown waters to blue waters, and depending on the scope, really having the right answer, so that you will see we reduce the exposure of man at sea. We also reduce the carbon footprint of the survey operation, and we have an increased quality of the data, an increased efficiency of the survey operations. And obviously, one of the challenges is the communication. So here we have also developed what we name Cortex, which is an embedded solution into our autonomous system that allows to communicate through SATCOM, 4G, broadband radio, Wi-Fi, for example. and allow you to control your asset remotely, fully remotely, so from the shore, and control the quality of the data, of course, and control the navigation of your autonomous vehicles. One of the key elements here of Cortex, I will run the video. Hopefully you can see it running. So this is, by the way, our nice facilities in the south of France, in La Ciotat Bay. And you will see an example of obstacle avoidance. So the Drix have acquire a target and will avoid it and resume its line mile. Obviously, it's an example. We will need to show a much more complex environment to prove, the efficiency of that. But we've been testing that for some time, and this is a working solution now, operational survey solution. And I thought that the obstacle detection and avoidance module was an important point to describe in autonomous systems. And this is the last part of my presentation. So I don't want to spend too much time on the offering, but just it gives highlights of what we are doing at XBlue. But here, what are the benefits and challenges? So first, on the path to net zero, we see autonomous system as being greener, faster, and better. I give a few numbers here to illustrate this position. The fuel consumption, for example, and it leads directly to the carbon footprint, but the fuel consumption on the Drix is about 2 liters per hour at a survey speed of 8 knots. So you will see, if you compare that to classical survey approach, that it's a massive reduction, 80 times, 100 times, maybe more, of the fuel consumption. And it's a subject of I would say, of thinking for sure. Should we have a diesel propulsion, an electric propulsion, or an hydrogen propulsion? This is something maybe we will discuss later today. But besides the consumption, the autonomy system is reducing also the exposure, so the crew exposure at sea, the man exposure. It's going faster, and as I said in the introduction, it is of a better quality because the quality of the signals, the quality of the sonars are enhanced by the silent approach of our autonomous vessel. So I give some numbers here on the fuel comparison between a Drix and an opportunity vessel. I compare 50 liters a day compared to 2,000 liters a day, or a footprint of 0.52 compared to 41.6. Also, we have seen that the processing time and many factors on the daily operation are heavily reduced. And we go further, now at XBlue because we want to enlarge the scope of autonomous system. So having payloads in a gondola is very interesting, but being able to tow system with unmanned system is something also that we are very proud of, and that we are starting to push in the market. So we see here a Drix, our autonomous survey vessel, towing what we call FlipX. So it's a Aero TV, so it's an active antenna that stabilizes automatically with respect to the seabed, okay, at a constant altitude, and that carries sonar, side scan sonar, and magnetometer, for example. So with this offering, now we can come in the market with a full spread of sensor that can be used for, I would say, shallow water up to 200 meter water depth, shallow water geophysical surveys. And it's, I think, a real move towards autonomy, and it's a real move toward reducing the carbon footprint. So it's real, it's operational, and probably we will discuss about that today too. So what unmanned surface vehicle will bring to the industry? I would say a drastic reduction of the carbon footprint. It's less fuel, it's less data processing, it's quicker operations, it's no exposure of manatee, it's an increased data quality. And what are the challenges? It is my last slide. What are the challenges on the technology adoption? We've been discussing with our clients and with our partners about risk and environmental assessment. It has to be done. We have done it. We have built a new concept of operation. It's almost like taking a new white sheet of paper and thinking on how we should do the surveys, how we should do the operations. There are challenges around authorization to sell, about regulations, which are still ongoing and very dynamic. It's, I think, a topic of discussion also today. And I put that in bold, the last point, because for me, it's very important thing is that despite, what we are talking about decarbonization willingness, there is no real rules today to motivate the use of unmanned technology. There is no real rule, as we have seen that, for example, in some countries, to push the electric usage of cars, electric propulsion. There has been some governmental take on that, and today there are not. So it's up to the willingness of the industry to move to unmanned technology, and it's taking a bit of time, I have to say. So this is my last point and my conclusion. Open for questions and for the chat with you, Bjorn and Justin.
Thank you, Olivier. So with that, we will transition, and Bjorn, you're welcome to share your screen and share your remarks. And just a reminder to the audience, I see one question come in, which is a good one, and we will look forward to that discussion after Bjorn's remarks.
Hello, everyone. So I hope you see my screen.
We do.
Great. Okay, thanks for the opportunity to present at this panel. Been looking forward to that. I think I'll probably mainly concentrate on trends and technology more than products themselves. So you will hear some viewpoints on the developments. And I think if you look at the maritime industry, the biggest thing with maritime industry today is, of course, that it emits around 2 to 3% of the total carbon dioxide of the world. So that's a substantial contribution to the greenhouse gas that the world experiences, the greenhouse effect that the world has. And a major undertaking necessary with goals and milestones within 2030 and 2050 is, of course, to then reduce the carbon emissions, the greenhouse gas emissions from the total maritime fleet. And Kongsberg, as many other maritime companies, we are in the middle of that journey, transition, to actually get the complete maritime fleet towards net zero. For this panel today, as I've understood with the discussions up front, there is more than maritime transport. We are also concentrating on blue economies and energy, food, minerals, blue activities happening on the ocean in addition to transportation. And I think a big picture now is that offshore oil and gas has, because of the climate changes, entered sunset. How soon sunset will happen is not super easy to say, but we are transitioning towards a greener world. So, and we are transitioning towards more blue economies, because as the population in the world grows, the ocean becomes more and more important to have good human life with necessary food, necessary space, necessary transportation, energy, and so on. So, and when we are now making these transitions to the new blue economies, I think building on human history, we really need to manage them sustainably from the start. And I think our industry with autonomous and unmanned solutions, we have a huge role to play in enabling these transitions to new blue economies. I mentioned seaborne transport that will become eventually greenhouse gas neutral. But I also think if we can deal with virus, tourism and leisure on the ocean is a very nice way for human beings and a good activity. But there's also vulnerable areas, so it has to be managed sustainably. With energy, when we will now start to build out offshore wind, there should be an environmental design of the offshore wind fields and environmentally so that the offshore wind fields do not destroy the marine ecology. And to ensure that, we need marine ecological monitoring. Same with minerals, marine minerals, which could become important in the future. And then the standard industries like of fishery that has a successful history of sustainable management. Aquaculture definitely needs it, and new industries like kelp. And so I think to really have enough information here, it is really a crowdsourcing of a lot of platforms. There will be data from research vessels, marine robotics, marine maritime vessels of any type, as well as coastal and seabed infrastructure, which in total contribute with enough data to really understand and monitor the ecological development of the oceans. So, and then there will be international and national organizations that provide ocean data platforms for turning data into information, and then governing bodies, national, United Nations, international organizations, taking information, and probably also from private data platforms, and then managing the ocean. So I think that's a big picture and a very important step forward. When it comes then to autonomous and unmanned solutions themselves, I think a few main technology trends, and several of these have already been mentioned by Olivier. Connectivity. We talk about autonomy, but I think in reality we talk about unmanned vessels, vehicles that have autonomy functions, but they are almost always connected. And there will be some sort of remote operation, also definitely autonomy. And there is a trend of having unmanned and self-propelled vessels. And that's a big thing, because when vessels become unmanned, they become much smaller than the manned platforms. And by having them smaller, we reduce greenhouse gas emissions a lot, but also in the maritime world, there will now be propulsion systems themselves with new fuels, new energy carriers that has much lower greenhouse gas emissions. And then as Justin said, robotics themselves are great contributors because they replace manned vessel operations, and they do the same jobs, or they complement with a very low energy consumption and greenhouse gas emission. This is an example from a survey company called Reach Subsea. They are doing pilot studies of replacing a standard offshore support vessel. This is mainly for IMR, inspection, maintenance, repair jobs. Typically 50 to 70 personnel and the concept and the pilot is to replace that with an unmanned vessel of 25-meter length. And as you see on the right, that significantly reduces capex, it reduces opex, as well as daily CO2 emissions. In this case, it's a hybrid vessel with battery and diesel. So, and it's a very exciting world to live in. There are a lot of multiple platform trends within our area. From a traditional manned vessels, we have now manned vessels with increased onshore monitoring and support, manned vessels with robotic force multipliers, unmanned vessels monitored from onshore, unmanned multi-domain operations, fleet operations, and even AUV and USV operations alone from shore. So I'll dive a little bit more into these variants. I think it's too early to really say what will be the most successful concept. But as with manned vessels, I think there will be a lot of concepts because there is a lot of wide range of solutions to be solved. And the connectivity and remote operation will be central. And connectivity, maritime radio, 4G and 5G, and satellite communication makes connectivity more geographically available, lower cost, higher bandwidth. I think the only thing that's sure is that this becomes better and better in the maritime environment. This is an example of a Kongsberg remote operation center. We are about to deliver these kind of centers. Typically have great video walls for situational awareness, and then near screen operator systems where you actually control the objects as you would on a bridge. And then I think there will be, in the remote operation centers, there will be several stages. A lot of vessels, manned vessels, will start with monitoring and support operations. Expensive or highly qualified personnel will be on shore, and this happens already. Then there will be more direct control, and we'll move towards autonomous operations and finally fleet operations from remote operation centers. To make this transition happen, of course, autonomy is important. Within AUVs and USVs, I think the traditional way for what has been an autonomous system has been to plan, collect the data, download the data, process the data, extract the data, and then act after, for instance, an AUV mission. We are definitely moving towards a lot of more in-mission processing, and already we have, based on in-mission processing, extract in-mission information and act in mission. And this will only be more and more of. So this is kind of mission autonomy, then of course also building on navigation autonomy as was shown in the video from Olivier. And this is an example of pipeline tracking where you combine several data. If you have interesting data, you can in mission decide to maybe take a better optical image. I talked about the main challenge of reducing CO2 emissions, and fuels of the future is a big thing. But there are several ways to reduce greenhouse gas. It's about minimizing the energy consumption of the vessels themselves and the robotics themselves. And there are a lot of automation that can be done to reduce energy consumption. And it's very important to have maximize the energy conversion efficiency. How efficient is your engine system, your power system, and your propeller system, and how is the totality, and how is the totality when used in your operations? And then, of course, as there's a lot of talk about the new clean energy sources. To a large extent, hydrogen-based fuel cells, based fuels, where then the creation of these, production of these fuels would come from greenhouse gas neutral energy sources like power and sun. By minimizing energy consumption and maximizing energy conversion efficiency, there is a lot of technologies, a lot of steps, things making this happen. And as an example, would you imagine if on a big tanker or a bulker moving from one continent to another, if you have clean hulls, you reduce energy consumption with more than 14%. And that's why, for instance, Kongsberg and Jotun has entered a partnership, collaboration, where we, as there are lawn movers on the green lawn, so in your private house, you can have a robot that clean your vessel all the time, and by that way reduce energy consumption a lot. And by the way, by always having clean hulls, you do not have transfer of invasive species from one continent to another. So a lot of development trends: efficiency and energy reduction, electrification and batteries, super central, and also the fuel transition. And then a few slides on the robotics. I think this is an example of Ocean Infinity. I was in the very central in the early days of the Kongsberg AUV business, and for years, I would say almost 15 years, the concept operation was to have one survey vessel and one AUV. And then some clever guys came around and say, well, if we have the big expenses of one surface vessel, why not get 5 times the data? So I think that's an excellent example of how by having multiple robots from one host vessel, you really get a very strong force multiplier. And this concept is now being developed for naval vessels. We'll see it in research. We'll see similar concepts in inspection, maintenance, repair, and so on. The combination of manned and unmanned platforms, and we call it also manned-unmanned teaming. So again, an example of how a naval solution would be, and maybe not that very different concepts from a future survey vessel or research vessel. And then we have the fleets of unmanned vessels, like again, Ocean Infinity with Armada. Quite impressive and quite revolutionary. And I mentioned a concept from Reach Subsea, where instead of they want to do ROV operations, but instead from a manned vessel, they will do it from an unmanned vessel. And this is maybe going one step forward. It's building underwater vehicles, autonomous underwater vehicles with long endurance. In the case of the Hugin Endurance, the AUV itself has 15 days endurance, you can go from Europe to America. And with a synthetic aperture sonar, you can in one mission, in one dive, cover 1,110 square kilometers with 3 centimeter resolution. Of course, advanced autonomy functions and also super accurate navigation can be used for commercial naval applications. And then all kind of connectivity, remote monitoring and supervision, as I've been illustrating, as well as the shore-to-shore operation concept. So in summary, I would say the future is both bright, very challenging, very interesting, and a lot of fun. And within autonomous vessels, unmanned solutions, there are a lot of opportunities. I think, as we've been discussing, main drivers are lower capex, lower opex, and lower CO2 emissions. Connectivity, autonomy, and remote operations will build on very solid system architectures, because it's necessary to have these solutions scale to fleets of robotics, as well as scale to fleets of traditional maritime vessels. So the architectures that we build now will be very important and very interesting to follow. there will be several competing concepts, and I think, and there will also be several parallel concepts in operation. Reliability and robustness will be the determining factor. Every time you let a robotic system go away, you need to be sure it comes back. And then just one sentence about Kongsberg. We are a technology provider to vessel owners and service providers. We provide the technology, so that's our mission. Okay, thank you.
Thank you, Bjorn. And so if you stop sharing, I think now hopefully what the audience should see will be our 3 smiling faces. And we will move into the Q&A now. And I will remind the audience, you may submit questions. I've seen a couple come in, and we will start using them. So I guess I'd like to, in my mind, we have 2 very powerful themes to think about here. One, of course, is technology, and you both did an excellent job of summarizing innovations and creative solutions and emerging trends. And then, of course, there's sort of the business case, practical realities of putting technology to work. So I'd like to start with the question. So the question came in, and this particular audience member may have missed my opening slides. The question's about wind power, solar, essentially renewable energy sources as a way to power and drive uncrewed systems. And so as a reminder, there are many solutions out there. There are robotic sailboats, there are robotic solar-powered boats, there are robotic wave energy systems. But in your cases, both of your companies are focused on solutions that do not use that approach. You either use stored energy in batteries or perhaps generators. Could you comment from a technical perspective on why that's the current dominant trend in the products you're bringing to market? And either one of you who's willing to step in, I'm not going to call on anyone first, but I'd love to hear your thoughts on your selections in that regard.
Maybe if I start, I think there will be many parallel power sources out there, as you said. But I think for the majority of vessels and vehicles, there will be some main solutions, and whenever endurance range allows, the best way to store electrical energy is in batteries. So that's why I think when you see robots that kind of with like 2 weeks endurance or vessels that are coastal vessels, short distance maritime transportation, ferries, they will have batteries and then they will charge regular because it's like an electric car. It's the most simple, best system to use for kind of a vast majority of applications. Then if you look at maritime transport between continents, deep sea, the batteries are not the efficient way of storing energy, and that's when we need a new fuel sources. And I think that's still to be determined. The most players in the maritime world, they believe it will be hydrogen or a hydrogen derivative, like ammonium or hydrogen itself, or synthetic methane, for instance. So it remains to be played out, but I think that will be interesting to follow. For specific robotics, I think there will be more specific solutions and a wider variety.
Yeah. Thank you. Olivier, comments?
No, yeah, I agree with what Bjorn said. It's there are some constraints, to answer, and obviously when you start looking at energy like the wind, so Saildrone, I think, for example, they took this approach, very interesting. Then it's about of what is the scope of your operation, what sort of power do you need on your unmanned system, and probably the Saildrone is answering to a number of applications as it is today. Again, what we have been looking at when we developed our unmanned surface vessel at X-Blue was, the capacity of energy you have in 1 liter of fuel. How can you get 1 kilowatt? And as Bjorn said in one of his slides, is reducing, the consumption. It's a triangle, on reducing the consumption. It's we see that battery, for example, on the Drix, if we want to power the Drix with battery, we will need 7 tons of battery. So the equation does not work, and the carbon footprint is not ideal at all if you look at it this way. So we took probably the side of saying, okay, we prefer to have 2 liters per hour of diesel or fuel rather than 7 tons of battery, which makes the business case completely impossible to achieve. So I think we are on the path. It's depending on the scope. If you have to launch and recover subsea assets, it will be very different to measuring oceanographic parameter in the water column. So it really depends on the scope. Really depends on the capacity of the assets.
Yeah, thank you both. And I would say, sort of from my perspective, those systems that I opened my remarks with, right, the ones that are powered by, say, waves, they also carry solar panels to recharge their batteries, and they have very clear payload limitations. The solar-powered robot boat that I showed you jumping through the waves, right? That company, as I understand it, is exploring carrying fuel and generators to extend and augment their range because of the things you pointed to. And the sail drone surveyor, the very, very large new sail drone, as I understand it, also is a multiple power source, right? So it has some solar panels, it tries to use wind for propulsion, but it also, as I understand it, is embarking generators, and that is driven in a sense by the payload requirements you've alluded to. So what I would take away to sort of close this question for the audience is that, all the technologies are in play. Selecting a solution that fulfills the end requirement is complicated, and it's driven by engineering choices, economic choices, and environmental choices. So we must balance that. I'm gonna change the subject a little bit. There's an excellent question here, coming from an operational perspective, an end user perspective, and it relates to the business model of technologies in these markets. And recognizing that you are both essentially technology providers, you make solutions that service companies typically take to market and sell their services to other end customers, right? But from that perspective, what do you see as incentives for those service companies to change their business model? The question recognizes that the current business model of many of these providers is selling essentially manpower, selling the humans, selling the ships, selling the capital assets that had already been amortized on the balance sheet for as high a day rate as they can. And we are now coming forward saying, hey, you should change your capital base. You should not bill people hours. You should bill robot hours, right? So it's a great question. I recognize that essentially you're not service companies, right? So you're not going to comment from that perspective, but certainly you work with a lot. So I'd welcome your thoughts on that great question.
Maybe I can start if you allow, Bjorn, on that one. One of my slides was about our capability to provide services. I don't know if you have it in mind. I think it is essential in this market, in the autonomy market, to support the client, to support the survey contractor. We cannot just be a technology vendor. We cannot just hand over the assets and stop the support will be probably a very, very big part of the adoption of the technology in the market. It's more than support, it's going along with our clients to educate them on the concept of operation, work together on the risk assessment, and build together the next model on how we will do the surveys. So So to answer the question on what motivates the survey contractor to move, to autonomous system, I think it's driven by their clients. It's driven first by this willingness of the world to have a greener and better world, to go on the path of net zero. And today we are seeing, organizations such as Total Energy, Equinor, Ørsted, a lot of majors are willing to move into this direction. For me, I would say too slowly still, but they are willing to move into this direction. And then you have, some survey companies who have appeared recently in the last few years and want to differentiate and want to, they are starting with no assets, and they have this opportunity, this big opportunity to actually take market share, because they will have a quicker, safer, better, greener approach than traditional methods. So it's a very good question. We are, asking ourselves this question all the day, but where we are today is to improve the technology and to make sure that the market as a whole, the ecosystem, can adopt the technology. And there are various challenges into that. We'll hopefully discuss it today. But this is what we do. So it's a little bit of a change of position as a technology, supplier. We have to go further in what we did in the past, in our proposal of a new concept and new technology.
Thank you, Olivier. We might have lost you a little bit at the end there, but great remarks. Bjorn, comments?
Yeah, to compliment Olivier, I think historically, as you mentioned, Justin, it's been an issue. I think, at least for a technology company point of view, that why don't the energy company or the clients go for these new great solutions? And then, of course, I understand the service providers. Why do new technology when the clients are happy? But I think with a change in oil price that happened, that changed the oil and gas industry a lot. I think in general we see a lot more eagerness, drive to save cost in oil and gas markets, and with everything now going on in offshore wind, I think that's also an opportunity for change. Because the new ways of doing things will be established, new processes, new procedures, and also in offshore wind. If we look at the full value chain, the green shift is dependent on sustainable energy becoming competitive, and regulations will be and taxes will be one way to make green energies competitive, but also offshore wind operations have to be extremely efficient. So so I think there will be a drive now, at least in the two energy segments, really to make the technology shift happening. So yeah, interesting.
Yeah, thank you, Bjorn. Yeah, so if I could sort of synthesize some remarks and one sort of historical data point just for amusement, I'm sure some of us remember. So the things we see going on with AUVs for deep water survey, for example. I'm dating myself, but I remember a day when deep tow was the default, right? And then along came the idea of, instead of two ships and a deep tow, you have one ship and one AUV, and that was a profound change. And I may be mistaken, but I think it was BP was the first operator who specified in an RFP that they wanted AUV data, right? That change, and this is sort of a specific answer to the individual who posed the question, an operator changed their RFP, and therefore the service companies had to buy AUVs, right? So that's one very clear lever. And then I think another one I hear being alluded to, even beyond regulation and taxation, is economic forcing functions. And my impression of this is, as offshore wind becomes more common, the amount of infrastructure in the ocean actually goes up. We need more wind turbines to generate the energy we retrieve from one oil well, for example. So now we have more assets in the ocean. To maintain and inspect those assets, we must get more efficient because we need to, and this is where these systems come in. So I'm hearing about customer choice. I'm hearing about market forces. And of course, we've mentioned, and throughout there is this theme of regulation and sort of the public sector's influence on the market. So no, a very interesting discussion. I'd like to stay on this angle for just a moment. We have 15, 20 more minutes. I see no interesting technical question we'll come back to. At the risk of going too far into being sort of too open and honest with ourselves and our audience, I'm curious if you could comment on your perspectives as to the balance of true imperative towards transitioning to green that you see in the marketplace versus, I'll use the words lip service, or sometimes people use terms like greenwashing or blue washing, right? We hear a lot about this topic. We're here talking about it. Personally, I'm a huge believer. I see a lot of challenges. Olivier did a great job of explaining why internal combustion and liquid fuels have excellent technical advantages, right? So to the extent you're both comfortable, could you just sort of comment on how you see that social, technical, societal interplay playing out in your own experiences? And please don't, obviously, we don't need to get too much into dirty laundry, but I'm really curious how powerful a force this is, how fast you see it unrolling in your own perspectives. So I welcome just any remarks you have on that front.
So maybe I could start then. Representing a European company that's not a member of the European Union, but we do have a very strong relationship, so we follow all the rules. And I would say, from a Kongsberg Maritime point of view, Olivier mentioned the EU taxonomy. And Kongsberg Maritime will be compliant with the EU taxonomy reporting, which is financial reporting regulated in Europe. And the whole purpose of it is really to avoid greenwashing and have for the financial markets true reports on the greenness of the business. And when you put that to industry is like ESG. Industry awakens, and I think we also see it in financial market. If you look at what's happening, funding for green initiatives they are relatively easily available if you have good projects. So I think there is a lot of true imperative happening out in the business world. This, of course, is dependent on international regulations. It is dependent on solar and wind becoming competitive. I think that is certain to extent will be dependent on tax on carbon dioxide emissions. But if Europe has definitely got its act together, and if the world can get its act together, I think it will happen.
Thank you. Olivier, any thoughts?
No, yeah, I think it's happening already. I think it's a move. I see that in Europe, at least in some part of the world, I see that people, it starts with the populations are taking, this awareness on living better for ourselves, for our children, and it's moving to a political level. And we see that for cars now, and we see that in the food, in the packaging of the food, in the shipment of our goods. Also, with what's just happened with this virus, with the COVID, we have taken some measure. Even at Blue, we understand that I'm careful myself about my carbon footprint. More and more. Should I travel? Should I, with the new media, with the new communication capabilities? So it's a whole sphere, I think, of going greener. It's happening already. I don't think, it could be perceived as greenwashing a few years ago, maybe, but I don't think it is anymore. I think there is a lot of fundings at the European Union also to push R&D and to push technology towards, a greener and reducing the carbon footprint of all the industries, from space to the underwater applications. But it's taking time. I think as a world, we are very good when we hit the wall. And we hit the wall, I think, a couple of years ago, 18 months ago, and we reacted, I think, with bad and good things. But hopefully we will not hit the wall, and we will be very responsive and continue this development that we started, for me, I would say 5 to 10 years ago.
Very good. Thank you. Thank you both. I'll add, so I'm in the United States. I think the dynamics may be somewhat different, but I would agree with the trends. So here, the acceleration and significant growth of investment driven by what we might call ocean impact, or general impact. So the role of finance, the role of insurance, right? So in the United States, we've had some hurricanes. We typically do wildfires. The insurance industry is a powerful lever, and so we do see these trends creeping through. Here they may be a little more driven by the market imperatives than the public sector regulation. That's kind of the way we do things here, but I would agree with the trends. I have one more question I want to come back to as our closeout, but we have a few more. We have enough time here. I'd like to go to a question that came in, which is sort of more, again, back to the technology. And it relates to the question of, do these smaller vessels, right? So these uncrewed and autonomous systems are just physically smaller. The question is sort of about maintenance and life cycle costs, and whether there's a savings to be had here. And so I'd ask you to hypothesize from both an economics, cost of utilization, cost of operation, and perhaps from an environmental impact, right? So as we see large crewed fuel-powered vessels being replaced, let's not worry about transportation. Just thinking about the industries we support here, ROV inspection, pipeline survey. Can you comment about, does size and complexity lead to significant savings here? Or are all the savings embarked really just in the reduction of human being costs, right? So we're taking away operator salaries, and we're replacing it with different operators, fewer human beings. Can you comment on the savings you perceive in the market? And is it a fair question? I hope it's sufficiently clear.
Yes. Well, the savings are as we see it, but again, with the return on experience that we have, which we are on the way. But the assets are and will be lighter and smaller. So by this factor, we will reduce OPEX costs. And it's not here only about the crew. It's about the overall cost that you have on a vessel of this type. These vessels will be very complex. They will be probably much more complex. They are much more complex than current vessels. Okay, so I think one very important point that is related to costs is the reliability. Because if these autonomous systems are not reliable enough, then your cost might be very important, at the end for the project. So redundancy on these systems is a key for me on the path to reliability and reduction of costs. And then to answer more directly on the question, the cost will be reduced because of the efficiency of these systems. Autonomous robots are very efficient in a global way, underwater, surface, in the air. They are coherent. They are reproducing, the exact path, the exact line. They are in this way better than a human, and they work 24 hours a day, 7 days, if they are redundant and reliable. So there are a lot of axes, maybe Bjorn will comment in more detail, but there are a lot of axes of cost savings behind the man, saving at sea, because we will still have people, staff, online, onshore, with different skills to remotely supervise these robots.
Thank you, Olivier. Bjorn, any thoughts?
Yeah, it's hard to add more value, I guess. I think Olivier mentioned it. By the virtual much smaller vessels and uncrewed vessels with kind of no human on board, the vessels become much simpler, much less steel, and a lot of maintenance and cost goes down, and energy consumption. So it's I showed one example from one company which has their figures out on the web, so it's public data, and they show in their system a reduction of 65% in capex and opex, and I'm sure there will be other reductions for other type of operations and vessels, but reductions are significant. And there's also maybe another aspect, and that the ocean is sometimes a very nice place, but it's also a hostile place, and it's huge. And so it also actually increases HSE, human safety,
yep,
by having less people out in the oceans doing kind of challenging work operations.
Great. Yeah, thank you both. Certainly insightful comments. And I think the reliability is a great one, right? There was a time not long ago when press releases would be put out saying, 100-kilometer survey run, or, cumulative 1,000 kilometers of survey data collected. And I think we've all become comfortable with the fact that we no longer need to put out such statistics. We mostly understand that these things work fairly well. They are efficient. There's a great deal of trust built up. And now we have the luxury of focusing on the economic value proposition, not simply the functionality, right? So it's an exciting time. If you're, again, I'm dating myself, but I remember plenty of these robots that didn't do what they were supposed to do, and lots of time wasted, trying to fix silly things that just work today. So it's an exciting time. We have sort of 5-6 minutes left here. I'm not seeing anything else in the Q&A box. I'd like to sort of close out with some visioning and some hypothesizing about the future. We have talked a lot about state-of-the-art, currently available technology. We've referred just sort of by nature to an industry that we all know quite well, which is typically energy, right? So for the most part, we're very familiar with oil and gas and the transition to wind. We've alluded to transportation and shipping. But if you imagine we do this panel again in 10 years, right? So this is the UN Ocean Decade is underway, right? And there's all this interest. So, in roughly 10 years from now, could you take a guess as to a market area, an ocean economy area, something like that we haven't talked about, that you think will have been significantly impacted by the technologies we're talking about? So outside the bounds of transportation and energy, what are you excited about the growth of our technology and our opportunity to deliver both economic and environmental value in the ocean dynamic? If you've got some ideas and you'd care to, I'm not asking for predictions that we're going to hold you to in 10 years, but just what's on your mind? What are you excited about moving forward? And either of you feel free to jump in. I didn't prepare you for that question, so you're allowed to take a moment.
I could maybe I start and then Olivier goes. I think there's one technical topic we haven't discussed a lot, and that's the digitalization. So in 10 years, I think we will be very used to kind of dealing with the robotics in the same way as we deal with our personal devices. Also, the industry has been digitalized and transformed as our personal lives. So and I think robots are kind of helping the transition of the whole maritime industry, because when you have a robot, you really want to digitalize all the data processing, turning data into information, and automating work operations. So, but when it comes to kind of the larger vision, I think maybe there will be multi-domain or multi-function areas out in the ocean. Maybe there will be combination of offshore wind and type of aquaculture. Maybe actually, for instance, offshore wind will have positive impact on amount of fish. We are usually very afraid of offshore wind, but I think everyone who has seen that when you put a structure down on the seabed, there is more sea life around it. And then if you have a wind park, I think you can either combine with other functions like aquaculture or various stuff, or maybe it actually becomes a wildlife habitat for fish where you don't trawl, and then the whole ocean becomes more filled with ocean, because that's where the species animal kind of they are freely growing, and then they go out in the open zones for catching. I don't know. I think the future is bright if we make ocean design, if we environmentally design. Now take the opportunity to environmentally design and monitor and run these new economies. I really think the future is bright.
Thank you, Bjorn. Olivier, thoughts?
Yeah, first of all, I look back 10 years ago, maybe 15 years ago, when the AUV technology, more or less started in the domain, and seeing where we are today and how mature is the technology. And it took all this time for the market to adopt it, but it is answering a lot of questions, and it has allowed, the exploration of oceans to go beyond the limits. And today, now if I put myself in the shoes of today and I look in the future, there is a very high demand for the knowledge of the oceans. When I say knowledge of the oceans, it's the water column, it's the seabed. There is an increase in demand by countries. If you look at countries like the United States, the UK, Australia, many countries need to map their borders, need to map the economic exclusive zone in the next years. And if you do that with classical methods, you won't make it. So there is a demand first. There is a very strong demand to do it, and then to do it in a greener way. So there is a demand. There is a willingness to do it. There is the technology readiness now, but we are on the way. What we discussed today is, the very early stages. We are doing that we are in the prototype, and we are starting to see, some industrialized solutions. It is very early stage on that. Many challenges to go through. I am sure that in 10 years, we will use this technology as force multiplier to explore in a greener way the oceans. And there are many markets where this is required, in the defense, in the energy sector, in the fishery market, in the scientific world, understanding better the currents, the dynamic of the oceans, and the impact on the weather, on the climate change is a key element. So yes, I'm very confident, and I really hope that at the political level, and also at the highest level of the ecosystem in our market, we will agree and push towards the development of this technology, and towards using more autonomous systems, because I strongly believe in it. And it's not just because I have an X blue hat. I really even myself use more and more artificial intelligence in my house for a greener approach. So I'm really a fan of this move, and I trust that in 10 years I would like to see this pitch again, maybe, and see where we are. But yeah, I'm positive.
Thank you. Thank you. Yes, and I will so there's a question about the affordability of these tools. I will use that and my wind down remarks here to suggest this, of course, is a webcast coming to us with Reed Exhibitions, and most of us perhaps who have logged in are familiar with Oceanology International. There are many variants of these tools. There are affordable variants, lower cost. They should be on display at Oceanology next year in London. And I can certainly say to both of my panelists, I hope to see both of you there personally. I'm looking forward to the chance, raising a beverage, coffee or otherwise together and continuing this discussion, because yes, the next 10 years will be very exciting. And so thank you, XBlue, for sponsoring this webinar. Thank you, Reed Exhibitions, for putting it together. And even though we can't really see you, we as the panel thank all of you out there in the internet who have logged on. So we're at time. With that, I will say we will conclude. Thank you so much. Cheers.
Thank you.
Thank you, everyone. Thank you, Justin and Bjorn.